In this video, let me consider one numerical on Thevenin's and Norton's theorem. Obtain Thevenin's and Norton's equivalent for the network shown below. This is the given circuit or network we supposed to calculate or find the Thevenin's equivalent circuit and Norton's equivalent circuit for this circuit. First, let me start with the Thevenin's equivalent circuit. Thevenin's equivalent circuit. So here in this circuit we can see that it consists of dependent source. So it is having voltage dependent current source. This is voltage dependent current source. So if circuit is consists of the dependent source, so to find the Thevenin's equivalent circuit we supposed to find three parameters. So here we supposed to find VTH, that is Thevenin's voltage. Thevenin's voltage is nothing but voltage across open terminals. Here terminal A and B is open. The voltage between these two terminals is known as open circuit voltage or Thevenin's voltage. Then we supposed to calculate short circuit current, that is ISC. So ISC is the current which flows between terminal A and B when terminal A and B are connected. That is known as ISC. Then we supposed to calculate RTH with the help of VTH and ISC. So these three parameters we must calculate to get the Thevenin's equivalent circuit if it is dependent source. So first let's calculate VTH. Now to find VTH, so here to find VTH the terminal A and B should be open. So here we can see that at terminal A and B Vx voltage appears. So this Vx voltage is nothing but VTH. So in this case Vx is nothing but VTH. So as we see here, the terminal A and B is open, no current flows in this branch. As this terminal is open, no current flows in this branch. Therefore, voltage across 3k ohm resistor is 0. That is, voltage across this 3k ohm resistor is 0. So now this entire current, that is Vx by 4000, will flow through 2 kilo ohm resistor. So therefore, in this case, the voltage across AB is nothing but VTH will be equal to voltage across 2 kilo ohm resistor plus 4 volt value. So therefore here we can say Vx is equal to, let me consider this is positive terminal, this is negative terminal. So Vx will be equal to voltage across 2 kilo ohm. So voltage across 2 kilo ohm will be 2k into we have Vx by 4000, that is Vx by 4000 plus 4 volt plus we have 4. So simplifying this, that is Vx equal to, we have 2000 into Vx divided by 4000 plus 4, or I can write this is 2000 by 4000 is nothing but 1 by 2, that is Vx is equal to, this is nothing but 0.5 Vx plus 4, or I can write Vx minus 0.5 Vx is equal to 4, that is nothing but 0.5 Vx is equal to 4, or Vx is equal to 4 divided by 0.5, which is equal to 8 volts. So therefore we can write Vx is equal to Vth is equal to 8 volts. So thus we found the Thevenin's voltage, that is Vth. So first parameter we already found, that is 8 volt. Now we are supposed to calculate ISC. So to calculate ISC, now the terminal A and B which is open, now we have to short it. So that is, if we short the terminal A and B, the current will start flowing. That current is known as ISC. So here we can observe one more thing. Here in this circuit, the voltage between terminal A and B is Vx. So when we short terminal A and B, the voltage Vx will become 0. So here when we short terminal A and B, Vx will become 0. When Vx is 0, this current source value will become 0. So this voltage, this current source value is equal to 0 means this is open circuit. So in that case, this current source does not exist as its value will become 0. So I can remove this current source as it becomes open. Let me remove this. So now the equivalent circuit looks like this. Now in this circuit we can find ISC. So here we can see that ISC is nothing but 4 divided by sum of these two. That is, we have ISC is equal to 4 volt divided by 2K plus 3K. That is 2000 plus 3000. That is ISC is equal to, we have 4 divided by 5000, which is nothing but 0.8 milliamps. So therefore value of ISC will be 0.8 milliamps. So now we found VTH and ISC. Now let's calculate RTH. So RTH can be calculated as RTH will be equal to VTH divided by ISC. So already we have calculated VTH, that is 8 volt, ISC is 0.8 milliamp. So simplifying this, we'll get RTH is equal to 10 kilo ohm. So this is RTH value. So now let me draw the Thevenin's equivalent circuit. So therefore Thevenin's equivalent circuit can be drawn as VTH should be connected in series with RTH. That is, we have VTH, its value is 8 volt connected in series with RTH. So RTH is 10 kilo ohm. This is terminal A, this is terminal B. This is Thevenin's equivalent circuit. So now let me calculate the Norton's equivalent circuit. Thevenin's already we found. Now we have to find Norton's equivalent circuit. So to find Norton's equivalent circuit, again it is having a dependent source. So even to calculate Norton equivalent circuit, we have to find same three parameters, that is VTH, ISC and RTH. So in Norton's equivalent circuit, in place of RTH we will use RN. Both are same. Norton's resistance or Thevenin's resistance, both are same. So now, so in case of Norton's equivalent circuit, ISC is connected in parallel with RN. So here ISC is connected in parallel with RTH or RN. So here ISC is, we have already found ISC, which is 0.8 milliamp. This is 0.8 milliamp, that is ISC is connected in parallel with RN. So RN is nothing but RTH, which is nothing but 10 kilo ohm. That is, the value of this is 10 kilo ohm, and to this the terminal A and B are connected. This is terminal A, this is terminal B. Norton's equivalent circuit. So this is Norton's equivalent circuit. Thank you for watching.